4.1 translations. Your essential question, how can you translate a figure in the coordinate plane? The exploration says for you to work with a partner, but I'm going to be your partner today. So let's see what's happening here. So what we're going to do is we're going to describe the translations that map the given triangles to their given images. So recall that we move horizontal first, then vertical on a coordinate plane, right? So if you're at like the origin, for example, and you were going to do a point, you were going to graph a point, then you would move along the x-axis first. That would be your first part of the point, and then you'd move up and down after that along the y-axis. So we're going to do the exact same thing here. So for example, triangle F gets mapped to triangle G. Okay, so triangle F is here, and usually what I do is I choose like a point. So how about I choose, these look like right triangles, so I'm going to choose like the right angle. And now I'm going to map it basically to triangle G. So if I try to get from this right angle to this right angle here, then I would go left 1, 2, 3, 4, 5, 6, and down 1. And that's exactly what they're doing. Okay, so let's do the next one. So triangle B to triangle C. Again, I'll just use that right angle because it's really obvious. Okay, so I'm going to go along horizontally first. So I'm going to go 1, 2, 3, 3 to the right, and then down 1, 2, 3. So I'm going to go right 3 and down 3. Okay, triangle A to triangle E. So triangle A is up here, triangle E is over here. So horizontal movement first. So I go left 1, 2, 3, 4, 5, and then I go down 1, 2, 3, 4. So left 5, down 4. Okay, and then the last one here, triangle D to triangle B. So triangle D is here, up to triangle B. So let's see, we're going to go left first, left 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6. So it was left 6 and up 6. In class, we'll watch a little video clip and then we'll talk about this. So this will be done in class. All right, coordinates you're very familiar with. Coordinates are the things that represent those points that we've been talking about on a coordinate plane. Okay, so you're used to seeing them as an x coordinate then a y coordinate. Okay, so coordinates show position of a point. Right, if I tell you that this is 1, 2, then you go to the right 1 from the origin and then up 2. So it tells you exactly where that point is located. While vectors, so this is the new vocabulary here. While vectors, and the way that vectors are written, you're not used to seeing this, look like this. So you have kind of these like, they kind of look like inequality signs actually, but basically it's in this like pointed, ordered pair. And what vectors do is they show how a point moves. On a coordinate plane. Okay, so let me give you some examples here and then we'll go back, okay? So, we're going to use page 174. So if you want to go back and read this page, you totally can. I'm going to help you here to fill in the blanks in the following descriptions. So vectors have both direction and magnitude. Okay, so they have a direction they're moving and then like a size. So in the diagram at the right, the vector PQ is named. Now this is how we name vectors. It kind of looks like a ray, but not quite. It's like half of a ray. So that's vector PQ. You start at the end point and you move towards where the arrow is going, and that's the other end of that vector. And its component form is again using those like pointy parentheses. Okay, so let's see here. We went from P to Q, right? We went right 5 and we went up 3. Okay, so basically it's just like writing a point. The only difference is you're saying like how this thing moved. How did P get to Q? Well, P went right 5 and then up 3. Okay, so in this, the horizontal component, horizontal meaning along the x-axis, right? Horizontal component is 5. And the vertical component meaning along the y-axis, is 3. Again, I encourage you to go back to page 174 and read through it. Maybe you'll find some other information that's more helpful for you. Now, a translation, and we reviewed this in our last overview of chapter 4, but a translation maps or moves the points, we'll use the points P and Q, of a figure the same distance in the same direction along the vector, along a vector, with a horizontal component and a vertical component, AB, to the points P prime, Q prime. So let's draw an example of what I've just talked about. And again, this came directly from page 174. So I'm talking about some figure that's got points P and Q. Okay, so in your textbook, I think it looks like this. Okay, so there's my segment PQ. Now, PQ originally had x1, y1, and x2, y2. Now, this thing's been translated or moved along a vector. That vector is going to be AB, whatever the horizontal and vertical components are, to a new location, where now I'll have P prime. I'll try and make them look like they haven't. Ooh, that was a lot of pressure. Try and make them look like they haven't changed. You might want to use a ruler. And this is Q prime, right? So this got moved over here to it's basically this is the image of the pre-image. Now, the points change. We've taken x1 and we've moved horizontally a units. So for P prime, your x coordinate is going to be whatever x1 was plus however far horizontally you've moved. And the same is going to be true for your y coordinate. Okay, so you're going to take that y coordinate from your pre-image and you're going to add your vertical component to it, however far up or down you've moved. So that's how you get the new coordinates for the image. Same here. For Q prime, you're going to take what your original point was and you're going to add to them how far over you moved and how far up and down you moved. So this would be x2 plus a, because the horizontal component is a, and y2 plus b. Now, if b is negative, if you're going down, or if a is negative, you're going backwards, then it would be x2 minus a, or x2 plus a negative. Okay, so for example 1, we're going to name the vector and write its component form. So notice that now this time you start at P over here, and you go towards the arrow. And again, a vector is always going to have a horizontal component and a vertical component. So the question is, how far did I go horizontally to get to Q? Well, from here it looks like I went 1, 2, 3, 4 units to the left. So that would be a -4. And how far up did I go? 1, 2, 3, 4, 5. Okay, so this is vector PQ. That's the name of the vector. And now let's write it in its component form. Well, let's see. The horizontal component is -4, and the vertical component is +5. So let's go back to what we did in the beginning, the example or the exploration, and let's write the component form of each of the translations that we described on the first page. So if we went left 6 and down 1, that vector is going to be -6, right? Because we went left 6 and we went down 1, so that's a -1, right? Your horizontal component is -6, your vertical component is -1. So if we go right 3 and down 3, what's that vector going to look like in component form? So right 3 is a positive horizontal movement, and down 3 is a negative vertical movement. So look like that. Okay, how about left 5, down 4? So in component form, left 5, that horizontal component means that you went -5, and then down 4, again, that's going to be negative vertical component. And then left 6 and up 6, so that'll be a negative horizontal component, -6, and then your vertical component is positive. So that's just another way that you can kind of look at or describing what's happening with these translations. The vertices of triangle ABC are these 3 vertices. We're going to translate triangle ABC using this vector. Now, yes, you can graph this, but you also don't necessarily need to. You can actually find the coordinates of A prime, B prime, and C prime just by doing what we did in this past definition here, right? So I can basically take that vector and I can add it to the X and Y coordinates and get my new coordinates. So that's what I'm going to do for this one, because I didn't give us a graph. Okay, so point A is 0, 3. So to get A prime, what I'm going to do is I'm going to take that horizontal or the X coordinate and I'm going to add to it the horizontal component. Well, that's really just 0 plus -1 or 0 minus 1. And then to get Y, I'm going to do the exact same thing. So for Y, it's going to be take your Y coordinate and then add to it the horizontal component or the vertical component, which is -2. So adding -2 is the same as subtracting 2, so that's the exact same thing. So basically now A prime will be -1, 1. So there is the there's the image's coordinate. This is the pre-image coordinate. Do the same thing for B. So I got 2, 4. So then B prime, you use the same exact vector. I'm going to take 2. It moves horizontally -1 or to the left 1. I'm also going to take 4. And it moves vertically -2 or down 2. So then B prime becomes 1, 2. There's your new vertex for your image. Okay, and then we're going to do the last one, which is 1, 0. So then C prime, and you don't necessarily have to write this all out. You could do a lot of this in your head. But I'm going to go ahead and take 1 and move it horizontally left 1 or subtract 1 from it. And then I'll also take 0 and move it down 2 or subtract 2 from it. So C prime is 0, -2. And you have your coordinates. So these would be the 3 vertices of the translated triangle ABC. Example 3, writing a translation rule. Write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. All right, so triangle ABC is this green one. This is our pre-image. And then it's been translated to A prime, B prime, C prime. Okay, so pick a point. I'll pick point C. And I'm going to follow point C along. I'm going to go horizontally. And then I'm going to go vertically. So to get from this C to C prime, or from the pre-image to the image, I'm going to end up going right 2. And then I'm going to go down 1. So in vector component form, that would be 2, -1. Write 2 down 1. Okay, so the way that we write the rule is that we basically write it out in coordinates. So we say for every coordinate x, y, it gets translated or it gets transformed into, well, every single x coordinate gets moved right 2. So I take the x coordinate and I add 2 to it. And every single y coordinate gets moved down 1. So I take the y coordinate and I take 1 away from it, right? Or add -1 or subtract 1. This is how we write a rule. So this right here, the whole thing is the rule. Take every coordinate, do a transformation. Here's the transformation. We'll do different transformations. Like we'll do reflections, right? And it'll look a little bit different than this. Okay, we'll do dilations. It'll look a little different. But the rules all pretty much get written like this. Example 4, translating a figure in a coordinate plane. So graph quadrilateral ABCD with these 4 vertices and its image after this translation. So here's, see, they've given us a rule, right? And we know from this rule, because we just did one, every x coordinate, what's going to happen to it? You're going to subtract 1 from it, or in other words, you're going to move 1 left. Every y coordinate, you're going to add 4 to it, or in other words, you're going to go up 4. Okay, so we'll start by plotting A, -1, or sorry, 1, -2. I went the right direction but said the wrong thing. So that's A. For B, I'm going to go 2, 1. For C, I'm going to go 4, 1. And D is going to be 4, -2. Okay, so let's see. I think I'll use my ruler to keep this a little bit neat. This looks like a trapezoid. 2 parallel bases, and then 2 legs that are not parallel. Okay, now maybe I'm going to write my B out here, outside of the polygon. Now there's a couple of ways to do this, but because we've already graphed it out, we might as well go ahead and just calculate it or count out the spaces. So again, our rule, we're going left 1 and up 4, or in vector form, it would be -1, +4, right? Horizontal component, every point gets moved left 1, every point gets moved up 4. So for this one, I can really just count. I can say I'm going to go left 1 and go up 4. 1, 2, 3, 4. That's going to be B prime. C, I'm going to go left 1 and up 4. 1, 2, 3, 4. That's C prime. A, I'm going to go left 1 and up 4. 1, 2, 3, 4. That's A prime. And D, I'm going to go left 1 and up 4. 1, 2, 3, 4. That's D prime. So then maybe I'll make these different, well, I'll do this first and then I'll highlight them. How about that? So they can kind of pop out at us. So my image is this first one. And my pre-image, how about I use this red pen? Will this show up? Yeah. So pre-image, image. Now, another way I could have gone about doing this is just taking every single point and applying the rule to it, just like we did up here. So if you don't have to graph it out, then you can just apply the rule to these points and find the new points, like we did in example 2. But if they ask you to graph it first, then go ahead and just, once it's graphed, you can just count. Okay, what is a rigid motion? So a rigid motion is a transformation that preserves the length and angle measure. Length means that everything stays the same size, right? If we're preserving the length, everything stays the same size. If we're preserving the angle measure, then everything stays the same shape. So we had 3 transformations that did this. One of them is translations. What are the other 2? Hopefully you remember. It's going to be reflections and rotations. Now, when we do these rigid transformations, or actually any transformations, you can do a composition of transformations. Composition just means doing more than one. Okay, so this would be 2 or more transformations combined to form a single transformation. So let's do a composition of transformations here. So this is performing a composition. We're going to graph segment RS with endpoints R and S. Okay, so let's start with that. So let's see. R is -8, 5 and S is -6, 8, which means I need to be pretty far over on the negative x-axis and kind of up on the y-axis too. And then let's see, I'm still going to move left eventually with my x values, and I'm going to go up even further on my y values. So I need to go a little bit further left than -8, and I need to go a little bit higher than +8 on my y-axis. So I think I will make a strange coordinate plane where I'm really focused on the second quadrant. Okay, so starting with RS, R is -8. 1, 2, 3, 4, 5, 6, 7, 8. And +5. 1, 2, 3, 4, 5. I'm going to label these R. And then S is -6 and up 8. 6, 7, 8. RS. Okay, so I'm going to do 2 translations. First translation is going to produce segment R prime, S prime. Second translation is going to then produce what happens after I just do 1 prime, 2 primes. Segment R double prime, S double prime. And if I did a third translation, I could do R triple prime, S triple prime, and so on and so forth. Okay, so for this one, I'm going to take every point and I'm going to go left 1 and up 4. So for R, I'm going to go left 1, up 1, 2, 3, 4. So let's see, that puts me at -9, 9. So that's R prime. And how about, let's see, I think I'll write it right here. -9, 9. And then S prime, I'm going to do the same thing. And again, because it's graphed out, I'm just going to go ahead and count. So left 1 and up 4. 1, 2, 3, 4. S prime. So let's see, that's going to put me at 13 and -7. So -7, 13. Making sure that they're parallel. They don't look parallel right now to me. 1, 2, 3, 1, 2. 1, 2, 3. Oh, there. Okay. All right, now from there, from R prime S prime, or from segment R prime S prime, I'm going to now go and do my second translation. So my second translation is going to, now every X value gets added 4, and every Y value gets subtracted 6. Or if you thought of this as a vector, right, it would be right 4, down 6. Make sense? Okay, so I'm going to go right 4, 1, 2, 3, 4, and then down 6. 1, 2, 3, 4, 5, 6. So that's going to put me at negative 5, 3. And that is now R double prime. Okay, I'll do the same exact thing with S. So I'm going to go right 4, 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6. That's S double prime, and that puts me at negative 3, 6. Make sure I got the same slope so I know that they're parallel, okay, because they should be, right? So the other way you could have done this is you could have taken this original point and you could have said, all right, let me subtract 1. Actually, you could have combined these and you could have said, well, really what's happening here for the final translation would be that X is 3 is being added onto X. See how I just combined those? And Y is being moved down 2. So that would have been just, if you just did this in one translation, this is basically what you would have done. Let's make sure that that's what's happened. From R to R double prime, I went 1, 2, 3, and down 2. Awesome. Okay. How does a translation differ from a reflection or a rotation? So these were translations. Notice I was checking my slope the entire time because they need to stay exactly the same orientation, right? Whereas a rotation, maybe I would have taken this and maybe rotated it 45 degrees. A reflection, I would have flipped it over, right? So it would basically look like it would have a negative slope, okay? So the biggest deal about a translation is that the same orientation is kept. Orientation is just the way that it's placed on the paper, right? This had a positive slope of 3 over 2, and they all did. The orientation did not change at all. They didn't get rotated. They didn't get reflected. That all stayed the same. All right, I think I'm going to leave this for us to do in class.